Let's talk about isoclines. Using slope fields, also known as direction fields, with isoclines, graph some solution curves for the differential equation dy dx equals x plus y. First, what are isoclines? For the differential equation dy dx equals f of xy, an isocline is a curve of the form f of xy equals c for some constant c. Why would we care about this? Along this curve, the slopes in the slope field will all be c. You'll see in a moment what I mean. So again, returning to the problem, using slope fields, graph some solution curves for the differential equation dy dx equals x plus y. There are different ways we can graph the slope field. So we could calculate x plus y all along here. Okay, here x plus y is 0, here x plus y is 1, here x plus y is 2, here x plus y is 3, kind of tedious. Here x plus y is negative 1, here x plus y is negative 2, here x plus y is negative 3. You can see how long it's going to take to do this. It's just so tedious and mind-boggling. Let's try it instead using isoclines. So instead of looking at all these points and saying, okay, what's x plus y here, what's x plus y here, what's x plus y here, we're going to look at, we're going to set this equal to a constant, and let's say that constant, for example, is 0. And then we're going to graph this curve, x plus y equals 0. So I'm going to graph it in red. X plus y equals 0, that can also be written as y equals negative x. So I'm going to graph the curve y equals negative x. Here's what the curve y equals negative x looks like. So, it looks like this. Just graph like this, blah, 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 blah. Okay. And now I'm going to switch the color of the pointer. So that pointer, that pointer was fine. Pen was great. We're going to choose a different color though. And the color, what color do you like? Which of these colors should I choose? Yeah, you're right. I'm going to go with green. That sounds good. Okay, so now all along this curve, notice this is the curve x plus y equals 0. So all along this curve, the slopes are going to be 0. So here's what our slope field's going to look like. All of these slopes are 0 because dy dx equals x plus y, and all along this curve, x plus y equals 0. Okay, now let's choose a different one. So pointer options, let's see, let's use the eraser. We don't want 0 anymore. Instead, let's choose x plus y equals, I don't know, maybe let's just choose x plus y equals 1. And as for color, let's see, what are we choosing as the color? X plus y equals 1. So let's just do a different color. Pen, yeah. And then let's go with pen, and I'm going to go back to red. Okay, so x plus y equals 1 is going to look like this. Okay, this is x plus y equals 1. X plus y equals 1. In other words, y equals 1 minus x. Okay, and now all along this curve, again, our slope field is dy dx equals x plus y, and x plus y equals 1 all along this line. So all along this line, I'm just going to graph little slope field tick marks which have slope 1. So let me change this. Pen, and let's change this to green. Okay, so we want slope 1 all along here. That's slope 1, that's slope 1, that's slope 1, that's slope 1, that's slope 1. Okay, so you can see it's a lot more efficient to do this if you use isoclines. Now, I'm actually going to go back and we're just going to do several of them at one time. So let's switch back to the red pen. First, I'm going to do x plus y equals 2. Here's what x plus y equals 2 looks like. It would go through all these points. And I'm going to label it so we don't forget what this is. So this is x plus y equals 2. Sorry, kind of slow and tedious to write this. X plus y equals 2. Okay, and then I'm going to do x plus y equals negative 1. So here's what x plus y equals negative 1 would look like. So I'm going to change this. Let's scratch out this 2. Let's just make that negative 1. X plus y is negative 1 is going to be all along here. So I'm just going to write negative 1 on here just so I remember. Then we'll also do negative 2. X plus y equals negative 2 over here. Okay, and I'm going to write a little -2. So again, now let's draw those little tick marks. Let's go back to pen. Let's change the pen color to our green. So all along this curve, we're going to draw lines with slope -1. So it's going to have -1. Actually, it's going to be parallel to this curve. It's going to be like this. Okay, kind of confusing. And then all along here, we're going to draw lines with slope, little tick marks with slope at -2. So -2 is like that, -2 is like that, -2 is like that, -2 is like that. Okay, and now, so now we've got our slope field. So we have a much better slope field. We were able to draw it much more quickly than we did when we did it in this tedious way like that. That just took forever. And now let's draw some solution curves. So I don't know what color we're going to draw for the solution curves. Can you just pick one of these colors? Yeah, blue sounds good. Let's do blue. Okay, so we've got this. Let's see. So if we start off with, for example, we start off with this. Okay, if you just start here, you just stay here. So this solution curve just parallels this. If, on the other hand, you started over here, let's say you start over here, you're just going to end up going up. You're going to go up. You start here, you're just going to go up. So again, this is just a matter of following solutions curves. If, on the other hand, you start here, you're actually just going to go down. So these are what some solution curves would look like. If you can't see where those come from, it's probably because I'm skipping steps. If you really wanted to see where they'd come from, we could draw in more of the little tick marks. But, you can only fit in so much in a video. And let's compare this with the actual answer. So if you want an online slope field generator, so you could enter a direction field generator, a direction field plotter, or a slope field generator, a slope field plotter into a search engine. This one's adequate. I actually like this one. And this is what you'd end up with. Notice that what we had is really more or less what we, this is more or less the same as what the search engine gave us, the online slope field generator. So we can generate a slope field pretty quickly using isoclines. But be careful, when you use these plotters, 2y plus x, for example, must be written as 2 times y plus x. And if you click on the plotter, you can plot solution curves. So what we had, it's kind of like what we had. Theirs are, of course, much slicker.